All right, lesson 9.7, three-dimensional figures and spatial reasoning. What's a three-dimensional? What does three-dimensional mean? What does 3D mean? What does three dimensions mean? For real, what does that mean? Real life. We live in 3 dimensions, right? What else? Explain, like when we talk about three-dimensional object, give me an example of what a three-dimensional object is. Triangle's not a three-dimensional object. Prisms, right? Cubes. 3D. Give me some other things that we see. Like what do you see up here on the stage that is three-dimensional? A box, right? What is this? What is a soda can? It's a cylinder, right? That's a cylinder. You know, that pen. The pen, what would you call that? Cylinder, right? Absolutely, definitely a cylinder. Anyway, here we go. So talking about a three-dimensional figure. A three-dimensional figure it doesn't lie on a plane. Do you remember what a plane is? A plane is like a piece of paper, right? Could a box be on a piece of paper? No, it couldn't be. It would take up more room than a piece of paper, right? I mean, it takes depth. So you've got a point, which is a little spot, and then you have like a plane, which is like a square. It's all the figures that we've been talking about: squares, triangles, circles, hexagons, octagons. I mean, those are all two-dimensional figures. All of a sudden, it's when you add depth, right? That all of a sudden it goes, whoa! Now it has stuff inside, right? Could there be anything inside of just a plain old circle? Could there be any like depth? No depth, right? 3D is a totally different. It adds a whole other dimension, right? That's why they call it a 3D, third dimension. So here's the deal. You know, a common type of here, I'll draw it properly here. A common type of 3D object would be like a rectangular prism or a rectangle or a square, a cube, or, you know, I'm not going to draw this perfect because I need to practice this probably. But, you know, you can see. What is that? What does it look like to you? A cube, a box, right? This is actually, well, we'll come back to this. Here's the deal. These things right here, I'm going to try and highlight this, see if I can do it. That side, do you see that side there that I spray painted? You know, that right there is called an edge. Sorry, no, that's not true. It's called a face. It's called a face. All right? How many faces does this object have? Look at it. There are 6. There are 6. Think about a dice cube, people. Think about a die, right? How many sides does a die have? 6. Can we name them? There's a top, a bottom, a front, and a back, and what else? A left and a right, right? Do you agree? That is the sides of a cube or the sides of a box. Agreed? Okay. The edge is any of these things. You know, like that's an edge. That's an edge. You know, like back here on the other side, you know, that's an edge. Do you see what I'm talking about? Those are called edges. Okay, those are edges. What do you think that these things here, like this, what about these corners? What do you think they're called? No? They are a vertex. They're a vertex. They're a corner. Math term for a corner? Vertex. Right? They're called a vertex. And a vertex, but if you want to get technical, the definition is where 2 edges meet. Do you see where at least 2 edges meet here? You know, like this edge right here. Let's see, what color can I use now? We'll use green. Where this edge, this edge here and this edge here, they met at the vertex. Where the 2 green edges meet is called the vertex, right? Where 2 edges meet is a vertex. Okay, here's the deal. This shape up here, this big shape up here that I'm going to circle in a lavender, I believe, that big object, it's not a shape anymore. Shapes are 2D. This is an object, right? You can grab it and hold it and shake it. That is called a prism. It's a prism. Here's the reason why. Here are some of the rules. A prism has two parallel faces. What in the world is a parallel face? What is a parallel face? Look here. Look. Do you agree that this sheet could be a face on an object, right? Like if I had an object like this, you know what I'm talking about? Okay, I've got, what is a parallel line? Parallel lines do what? Go on forever, right? Could be like this, whatever, but did they ever touch? No. A parallel face is like a parallel plane. Let's say this is the top of my box, and this is the bottom of my box. Are they parallel?
Yes.
Would these two things, if they went on forever, would they ever touch? No. Since that is true, and so it's two parallel faces that are also congruent. Two congruent parallel faces. Do you agree that the top and the bottom here are the exact same shape?
Yes.
Right? And they never touch? Those are parallel faces. Prisms have two parallel faces. Does this object here have two parallel faces? If you look at the other face over here, I'll try and do the yellow inside there. Do you see what I'm talking about? Do you agree that those two faces are parallel, Morgan? Do you agree that those two faces are parallel? They're like side, like this way, and they would never touch? Are they the exact same size? They're a box. So, people, if you look at this box here, I mean, is this side the exact same size as that side? Yes, they're exact same size, right? And are they, if these things were to go on forever, would they ever touch? No. Prisms have two parallel faces that are congruent. Two parallel congruent. I will put congruent. What's congruent mean? Same everything, right? Identical. Two parallel congruent faces called a prism. Whatever, and those are actually called, the two parallel congruent faces are actually at this point called a base. Okay, they're called a base. And whatever the base is what you call that prism. So since this guy up here, what is that object? What is that base now? That face, which is now a base, what is that object? It's a rectangle. Do you agree that each of those faces are rectangles? Do you see it? Sladen, do you see it?
I see both faces.
Do you see that both of those faces are rectangles? And faces that are parallel to each other and are congruent are also known as a base, right? Whatever the base is what you call the prism. So then, if the base in this situation is a rectangle, what do you think we're going to call this prism? A rectangular prism. It's a rectangular prism. If I had an object that looked like this, I want you to see, tell me this, is that a prism? How is it a prism? You tell me. How is it a prism? Where are the two congruent faces? Where are they? The top and the bottom in this situation. Do you see that the top and the bottom are parallel and they are congruent? Do you see it? You have to be able to see this. There's not going to be a lot of math in this lesson. You have to be able to see this. Do you see how they are congruent and they are parallel? Yes. Since those are the faces, listen, I have a question. I'm going to color this next one, whatever this ugly color is here. Is this guy over here that particular face, and this face over here, the back face, are those parallel?
No.
What does parallel mean, Jonathan? Parallel means the same?
Two lines that never touch.
Not two lines that never touch. In this situation, I'm talking about two
Faces.
faces that never touch. Does the back over here, does this guy over here and this guy over here, do they touch? Look at it. Do those faces touch? Does the back of this object, see how there's it's kind of pointing this way? Does the back here and the front here, do they touch along that line right there, along that edge? Yeah, they do. Since they touch, can they possibly be parallel?
No.
What does parallel mean, Jonathan? Oh, two faces that never touch. So if they touch, then are they parallel? No, they're not. No. The two yellow shaded boxes there that I have, do they touch? No, they don't. They're parallel. Let's talk about the back side over here. On this side of the, you see the object here? What about the back side over here? Is that thing parallel with the front side over here? No, why not? Because they touch. Where do they touch? Right here? Don't they touch right here? Oh, they touch. So are they parallel? No, they're not parallel. Right? Not parallel. Question? Yeah.
So this would be a triangle?
So here's the deal. Let's talk about it. What is the base then? What's the base of this object? It's a triangle because there they are, right? You're looking right at them. They're right here. That guy and that guy. Do you agree? Okay. Since the base is a triangle, then this would be a triangular prism. Right? What if I had an object like this? What if I had an object like this? Is it a prism?
Yes.
Why is it a prism? No, it's not because it's three-dimensional. Why is it a prism?
More than one face.
Two parallel faces. Two parallel faces. Where are the two parallel faces? The top and the bottom in this situation, right? There's one of them. And there's the other one, right? It's a prism. What kind of a prism is this? A hexagonal. Why hexagonal? Because what? Don't say it's. Because the base is a hexagon, right? Notice this, and this is true for all these shapes. What are the sides? What are the sides of this object? They're rectangles. All prisms have rectangles for sides. Even the triangular one. Even the triangular one had rectangles for sides. Do you see the sides? What are the sides here again? Rectangles. Right? Question, Sladen? A cube is a prism. It does. Is a square not a rectangle? Is a square not a specific rectangle? Is a square a rectangle? Yes. Is all rectangles squares? No. But are squares rectangles? Yes. Does that make sense? Okay. What about this then? What about this? Stay still. Stay still. What about this? Tell me what kind of object that is. That's a pyramid. Okay. A pyramid is a three-dimensional figure with one polygon for a base. All the other faces are triangles. This has only one base. Do you see any parallel faces here? No parallel faces, right? Do you see, what is the base down there? It's a rectangle. You might say it's a square, but are you sure it's a square? No. Can't be sure. So what would you call it then? If you're not sure it's a square, then it's a rectangle. And then what are the sides? What are the faces here? Triangles. This is called a pyramid. You should know that from looking at the Egyptian pyramids, yes? Right? I mean, you should know what a pyramid looks like. What kind of a pyramid would this be called then? We, again, name it by its base. Right. Here's the deal. This is definitely it's a rectangular pyramid. What about this? What about this? What if I have this guy right here? What's that thing? No, not a hexagonal. No, no. What's the base? What's a hexagon mean? 6 sides. How many sides does that base have? It's a 5-sided base, which is a pentagon. And so it's what would you call this object then? A pentagonal prism. Right? A pentagonal prism. Here is the other type of, would be this right here.
How is it a prism so it doesn't have parallel?
Did I say prism? I meant pyramid.
Oh.
That's a pyramid, right?
Yeah.
That's a pentagonal pyramid. If I said prism, I made a mistake. What is that object? Cylinder. What is a cylinder? What else could you call it? You could call it a circular prism, but it's not. We call a circular prism a cylinder, right? Two circles that are what? Parallel, right? Two circles that are parallel and congruent. Coke can, right? They form a cylinder, right? People, all these shapes are on page 449 and 450. All of them. Do you see them? They're all there. Okay, what about this? What about a... Can you? What is that? What does it look like? It looks like a birthday hat, or what else does it look like? Maybe an ice cream cone, right? Or a snow cone, right? Makes sense? A cone. Tell me, what does a cone have? How do you know? What makes it a cone? One circular base with a single vertex above it, right? One circular base and one vertex. Okay, and then the last one, which is tough to draw because it's tough to draw, that looks like a circle. So a lot of times you'll see somebody do they'll draw this little like this to kind of show that it has some depth to it. You know what I'm saying? What is that object? If it's like we call it a ball, but it's not a ball. It's called a sphere, right? How many faces does a sphere have? Just one big face, right? There's no vertex, there's no edge. It's just one big face. Does that make sense? In the end, people, here's the deal. When you do your homework, make sure that when you name your stuff, that you name it as specific as you can. If I give you this question right here, if I give you that guy, and then I give you that guy, and then we're doing our, there's our edges, and you tell me that is a prism, I mark it wrong. That is not specific enough. What should you call this? A rectangular prism. Does that make sense? A rectangular prism. If you tell me that this guy right here, that If that is a pyramid, I mark it wrong. What is that object? That is a triangular pyramid. Why is it a triangular pyramid? Because the base is a triangle. Does that make sense? Okay. Tonight's homework is not difficult. It's just you recognizing the shapes. So here, I'll give you your homework. I'll give you your homework. Just be patient. I know you can do it. Page, oops. Page 451 to 452, 6 through 15 even, and 22 to 24 even.